problem from constrained motion of particle dynamics, right? The problem is a particle slides down the smooth curve y, this is equal to a sine hyperbolic x by a. The axis of x being horizontal and the axis y downwards, starting from rest at a point where the tangent inclined at alpha to the horizon, so that it will leave the curve when it has fallen through a vertical distance a sec alpha. We have to prove the vertical distance the particle fallen is a sec alpha. Now we sketch a rough picture of this condition. Let this is x-axis and let this is y-axis, and this is the curve. At any time t, the particle be at t, where the tangent makes angle psi with positive x-axis. Let it be positive y-axis. This is origin. Okay, and at that time, this is the normal reaction at perpendicular to the tangent, and this is the weight acting vertically downwards. Okay, if we draw a horizontal line from the point P, then it is also psi, because this and this are the alternate angle. Now, if A be the initial position where we let this y, that is AM, let AM, this is y0, and at A, psi this is equal to alpha. Okay, and V this is equal to 0, because from here the particle slides down from the point or from the initial point A. Now let the arc AP, this is equal to S, and the equation of motion of the particle at any time t, that is at the point P, we consider here the tangential and normal equation of motion. And the tangential equation of motion is V dV ds. Sorry, this is mv dv ds, and the right side is the component of r along the tangent t at P is 0, because this is r cos pi by 2, so this is 0. And the component of mg, this is equal to mg cos pi by 2 minus psi, that is mg sin psi. Okay, so the right side is mg sin psi, and we cancel out m from both sides, v dv ds, and this is equal to g into dy ds. Since we know that sin psi this is equal to dy ds, and the coordinate of the point P is xy. Okay, so we get from here v dv, this is equal to g dy, and integrating this relation we get v square by 2, this is equal to gy plus a by 2, or we let this is c1 by 2, this is integrating constant, and v square this is equal to 2gy plus c1. And by putting the initial condition, that is the condition at A, we get v this is equal to 0, 2gy0 plus c1, so c1 this is equal to minus 2gy0, and now put the value of c1 here, we get the relation v square this is equal to 2g into y minus y0. Okay, we name this relation as relation number 1. Now we consider the normal equation of motion, which is given by v square by rho, mv square by rho, and we always taken inward normal as positive normal. So along the inward normal, the component of mg is given by this angle is, this is pi by 2 minus psi, and this is total angle is pi by 2. So this is pi by 2 minus pi by 2 minus psi. This is psi. Okay, so the component of mg along inward normal is mg cos psi. So this is mg cos psi minus r, right? And we get m v square by, now we have to find the position where the particle leave the earth. We know that a particle leave it car when r is equal to 0. That is, there is no touch of particle to its car. Then the normal reaction is 0. So we put here r this is equal to 0. Okay, and let at that point psi is equal to psi. Let it be any general point. Okay, now we get m v square by rho, this is equal to mg cos psi, because r this is equal to 0. And if the particle leaves from this point, then we have to find the vertical distance from A to this point. This distance we have to find out. If we name this point as K, then we have to find the value of MK. And also we let here the value of MA is y0. So our required result is MK minus MA. We have to find this quantity, right? And since the vertical depth of P is y, to find y from this condition, we put the value of v square from relation number 1 to this relation and get m cancel out, and this is 2g y minus y0, this is equal to g rho cos psi, right? This is the relation, and we cancel out g also, so we get 2 into y minus y0, this is equal to rho cos psi. Now we name this relation as relation number 2, and we know that cos psi, this is equal to 1 by 6 psi, and this is equal to 1 by root under 1 plus tan square psi, right? So we put here 1 by root under 1 plus dy dx whole square, because tan psi this is equal to dy dx whole square. Now we get rho into cos psi. We require the result rho into cos psi, and we also know the value of rho is 1 plus y1 square whole to the power 3 by 2 by y2 into cos psi means 1 by root under 1 plus y1 square, because y1 is dy dx, and this result gives 1 plus y1 square by y. Okay, this is rho cos psi. Now from the given curve, this is given by y, so we get y1, this is equal to cos hyperbolic x by a cancel out, and y2 this is equal to 1 by a sin hyperbolic x by a. and we put y1 and y2 here, we get as 1 plus cos hyperbolic square x by a by y2 means 1 by a sin hyperbolic x by a. Know that the result as cos hyperbolic square theta minus sin hyperbolic square theta, this is equal to 1. So we get cos hyperbolic square theta, this is equal to 1 plus sin hyperbolic square theta. We put the value of this in here, so we get rho cosine, this is equal to 1 plus 1 plus sin hyperbolic square x by a into a by sin hyperbolic x by a. Now put the value of sin hyperbolic x by a from the curve, we get the result as a into 2 plus, this is y square by a square by y by a. So we get the result as 2 square plus y square by value of rho cosine, and we name this relation as relation number. Now we put the value of rho cosine from 3 in 2. Get the value of y minus y0, this is equal to root under 2 square plus y0 square, and we name this relation as relation number 4. From the given curve, we get the value of dy by dx, this is equal to cos hyperbolic x by a, and this is given by tan psi, this is equal to root under 1 plus sin hyperbolic square x by a. Okay. Now by putting the value of sin hyperbolic x by a, this is given by 1 plus y square by a square. At the initial position where the particle is at a, from which the particle slides, then psi this is equal to alpha and y this is equal to y0, right? And in this case we get tan alpha, this is equal to root under 1 plus y0 square by a square. So we get y0 square plus a square, this is equal to a square tan square alpha. Now by putting the value of y0 square plus a square, this is equal to a square tan square alpha, here we get the relation as, hence finally we say that y minus y0, this is a sec alpha, so the vertical distance fallen, this is mk minus ma, this is equal to y minus y0, this is a sec alpha. Okay, this is the complete proof of this problem. Thank you for watching.